So let's start with the next topic. It is a dot convention only, but different type of numericals. The first numerical says find the equivalent inductance of the network shown. So this is the network, current I is flowing towards right, and these are the dots, right? And this indicates what? Mutual inductance. So there are three mutual inductances and three self inductances, right? So how to solve this? So what we have to find the equivalent inductance. So it will be what? Let's calculate due to this. So it will be the inductor of 1 Henry itself. Let's call it as L1, and it is having a mutual inductance or a shared inductance with L2. So what is that? It is indicated as M12, and if you see, it is what? Both are towards the entering part, so they will aid each other. Since they will aid each other, it will be plus M12. Now first and third also have a mutual inductance, so again it is entering, right? So it will be what? Again plus M13. So this is for the first part. Now let's go to the second inductor. What will it be? Plus L2. Now what is it sharing with 1? It is sharing a 0.5 Henry inductor. Again both are entering. So plus M23. Then again sharing with 3. Sorry, this is M21. Then sharing with 3. So M23, because they are again adding. In fact, all are aiding each other. If you see, all are towards the entering part. So I can directly write for the third, L3 plus M31 plus M32, right? So what is L1? It is 1 Henry. So 1 plus M12 is 0.5, M13 is 1 plus L2 is 2, M23 is 1, M23 is 1, M21 is 0.5 plus L3 is 5, M31 is 1, and M32 is 1. So what is it? 2.5 plus 3.5 plus 7, 7, 10, 12, so 1300. So this is a simple numerical. The final answer is what? 1300. Again, what you have to do? Just check whether it is entering or exiting, and depending on that, if it is both are entering, means they aid each other. So addition. If they are opposing each other, it will be minus. There was no question of minus here, no question of opposing, so no minus here. So let's see a question which includes opposing also. So now same question, find the equivalent inductance for. So what is the thing here? For this it is entering, but for this it is exiting. So it is a opposition here. So again L equal to, let's take L1 plus M12, both are entering. So plus, for M13, what is it? Exiting. So what will it be? Minus M13. So minus M13 plus, again start with L2. M21 is what? Entering. So plus M21. This is exiting, entering and exiting. So opposing each other. So minus. So minus M23. Then finally plus L3. So L3 and 1 entering and exiting and entering. So minus M31. Here also exiting and entering. So again opposing. So minus M32. So let's substitute the values. So it is 10 plus 2 minus M13 1 plus L2 is 5 plus M21 2 minus M23. M223 is 1 plus L3 is 6 minus 1 minus 1. So it is 10 plus 2 12 minus 1 11 plus 7 minus 1 6, 6 minus 2 4. So 17 21. So unit of inductor is Henry, right? So inductor value is what? What is the equivalent inductance? 21 Henry. If you want, you can mention this as L equivalent, but L is also fine. So now find the equivalent inductance for this. What is the difference here? Instead of directly the inductance, they have given the value of K. So K is nothing but coefficient of coupling. So what is K? Coefficient of coupling, and it is given as for a mutual inductance M equal to K between, let's say, 1 and 2, K root L1 L2. Okay, So first we have to find the mutual inductances because they have not given it. So for M12 it will be same as M21. So it will be K1 root L1 L2, right? Because we are taking the first inductor. So what will it be? K1 is 0.33 into square root of 12 into 14. So what is it? 0.3333 into square root of 12 into 14. So 4.28. So similarly M23 equal to M32 equal to K2 root 23. So L2 L3. So I'll directly substitute now. It is 0.37 into square root of L2 L3 14 into 14. 14 into 14. So 5.18. So 5.18 Henry. So M31 equal to M13 equal to K3 root L3 L1. So K3 is 0.65 square root of L3 L1. So 14 into 12. So 8.425. So 8.43 Henry. Right? So what is L? Again same procedure. L1 then 1 2 entering and exiting. So minus M12 plus M13 plus L2 this is again exiting and entering, so minus M21 again exiting and entering, so minus M23 plus L3 this is exiting and entering, so minus M32 and again exiting and entering, so minus M31, so equal to 12 minus M12 is 4.28 plus M13 8.43 plus L2 is 14 minus 4.28 minus 5.18 plus L3 is 14 minus M32 5.18 minus M31 8.43. So let's substitute in calci, we'll get the answer. So 12 minus 4.28 plus 8.43 plus 14 minus 4.28 minus 5.18 plus 14 minus 5.18 minus 8.43. So 21.08. I think I have made some mistake. 12. L3 M31 is both are entering, right? Both are entering, so this will be plus. This will be plus. So here I have to first add 8.43 plus 8.43. So 37.94. So L equal to 37.94 Henry. So this is the final answer. So find the equivalent inductance for the network shown. Same question, but they have asked in a different way. Right? So what is it? The two inductors are in parallel and these are the dots. And mutual inductance is 8 Henry. So we'll write for coil A. What we have the inductance LA. It will be the total inductance of L1 with the shared one. So there we see they are opposing, right? So if you see the current is entering here, it will get split here like this. So here it is entering, but here it is exiting. So they are opposing each other. So minus M12. So 15 minus 8 equal to 7 Henry. So similarly for coil B, What will be LB? L2 again different, so minus M12, so 16, strictly speaking M21, so 16 minus 8, so 800, right? Now we have got the LA and LB, right? So what will be the inductance? It is in parallel, so inductance is in parallel or same as resistance is in parallel. So 1 upon L will be what? 1 upon LA plus 1 upon LB. So we can directly write therefore L equal to, you can use this in the exam also directly. So LA is 7 inverse, LB is 8, so 8 inverse, then inverse, so it is 3.7333 Henry. Right. So this is the way you have to solve this sum. Let's take one more sum. Find the equivalent impedance across the terminals A and B. So this is A and B. What is the difference here? You have the inductors, but apart from that you have resistances also, and we have to find the equivalent impedance. So let's write the impedance first. So Z1 is 5 ohms, Z2 is 2 plus J4 ohms. See, I am writing in left to right way, but you have to always follow top to bottom approach in the exam. Remember that. So Z3 is 3 plus J3 ohms. And what is Zm? It is this shared thing. So Zm is J2 ohms. So what will be the total impedance? You can directly write Z equal to. So it will be this. So it is Z1 plus. These are in parallel. So Z2, Z3 upon Z2 plus Z3. But there is a mutual impedance also. So how to take that into consideration? For that there is a formula. So it will become minus Zm square minus 2Zm. So you know everything. So you can just substitute here and you will get Z. So just solve this. So 5 plus Z2 into Z3. So what you can do, instead of again typing Z2 and Z3, you can store it. So 2 plus, so first go in complex mode. So Z2 is 2 plus 4i. So store it in A. How you have to store it in A? Shift RCL A. If you have to store it in C, shift RCL C. 2 plus 4i I have stored, then 3 plus 3i. So store it in B. So my Z2 is A. Z3 is corresponding to B. So it is Z1 is 5. So 5 plus fraction. This is A into B. So A B minus Zm square. What is Zm square? 2i square. So in fact you can store this also. So 2i shift RCL C. So 5 plus alpha A alpha B minus alpha C square. So you see it becomes so simple. So alpha A plus alpha B minus 2 alpha C. So we have got the answer in a jiffy. So this is 6.294 plus J 2.824 ohms. So if you write it in polar form, shift to 3. So 6.9 angle 24.161 degree. What is the unit? Ohms. Right, so this is the final answer. So this is the way you have to solve the example. So let's have some homework problem. So the question is, find the equivalent inductance for, and the network is given as such. So we have taken two inductors in parallel. So the complexity is just increased by a factor of 1. So this is 25 Henry, 30 Henry, 35 Henry. See, I can use different sketch pens to show the dots, then the lines and the values. But I use the same sketch pens purposely because in the exam you will have one color only. So to acclimatize it with the exam, I am using the same color. So this is 15 Henry. And this is 10 Henry. Then you have between 1 and 3. What does this indicate? It is between 1 and 3. So it is 10 Henry. Right? So what is happening here? For it is entering, for it is exiting. So for this, inductance is adding. So it is plus. For first and third, it is minus. Second and third, it is minus. Entering and exiting. Right? So this way you can solve. So what we'll do, you'll write. So this is given as A, B, C. So you can say for coil A. I'll do it for coil A. So LA equal to L1 plus between 1 and 2 both are entering, so M12. Then between 1 and 3 this is entering, this is exiting, so minus M13. So what is it? 25 plus 10 minus 10. So therefore LA equal to 25 Henry. Right? Similarly find LB, LC. Then what we'll do? For finding L, 1 upon L, all are in parallel. So 1 upon L is 1 upon LA plus 1 upon LB plus 1 upon LC. So you can find L equal to. So you'll get the final answer. Right? So this is the way you have to solve this type of sums. Thank you.